guys, welcome back to this channel. If you're new, then welcome to this channel. Well, I'm back with one more interesting project using Python. Well, it's all about base converter app using Python. This is really interesting. I think you guys already know that we have different types of numbers. We have integers, we have decimal numbers, which are nothing but integers. We have hexadecimal numbers, we have octal numbers, we have binary numbers. There are many different forms of numbers, and for example, you want to convert decimal to binary or binary to hexadecimal. If you want to convert those kind of numbers, then at that time this base converter application will help you a lot if you are working with those kind of stuff. So here what are we going to do is we are actually converting the number bases, and this is nothing but a way of expressing the numbers. There are variety of number systems that we have, such as binary numbers, decimal numbers, hexadecimal numbers, and octal numbers. There are many different numbers are also there, but usually most of the time we use these numbers while we are working. For example, you want to convert binary to decimal or decimal to hexadecimal or octal to binary. At the time you have to follow a kind of logic at the time. So how can we do that? If you're converting that manually, you have to follow that logic manually. Like, this is the general representation of number systems. For decimal number, you'll be giving base 10. Binary number will be base 2, octal number is nothing but 8, which will be base 8, and hexadecimal number is base 16. Like, if you want to convert any number to any type, like for decimal to octal or hexadecimal to decimal, at the time you have to follow these bases, which actually represents the number. How will you know that a particular number is a decimal number? How will you know that it's a binary? How will you know that it's octal, hexadecimal? So in order to understand what type of number it is, for that you have to follow the bases. Yeah, this is the general representation of numbers. And here we are going to follow a table for converting the numbers, because binary numbers look something like this, and these are octal numbers, these are decimal numbers, and these are hexadecimal numbers. Alright, binary numbers are with base 2, remember this guys, octal number base 8, decimal number base 10, and hexadecimal base 16. Okay, for example, we want to convert binary to decimal or decimal to hexadecimal or hexadecimal to octal. We have to follow this particular pattern. If you see binary numbers, 0 is actually starts with 0 0 0 0. It's actually with base 2. This is how binary numbers exactly represents. Binary will be having just two numbers, one is 0 and one is 1. No matter what number it is, you are going to represent that numbers with zeros and ones. This is all about binary numbers. And octal numbers, remember that it will start with 0 and it will be up to 7, because octal numbers only 8 values, and once it reaches 8, like 7 0 1 2 3 4 5 6 7, again it will start at 1 0 1 1 1 2 1 3 up to 1 7, and again 2 1 2 2 2 3, something like that. And I think you guys really know decimal numbers, because those are the numbers that we use in our daily life. Okay, so this decimal number actually starts with 0 and will be up to 9. Total values are 10. Once it reaches 9, it will start again with 1 0 1 1 1 2 up to 2, up to 1 9, and again 2 0 2 1 2 2, something like that. Hexadecimal is a bit interesting and different as well. If you see here, it is similar to decimal up to 9, but once it reaches 9, from 10 it will use alphabets. Okay, 10 will be A, 11 will be B, 12 will be C, 13 will be D, something like that. So these are the actual numbers which people most of the time use while working with these numbers. Okay, let's try to work on converting these numbers, and the API looks something like this. Let me show you. Yeah, it looks something like this. If you see here, and we have binary, octal, decimal, and hexadecimal. For example, I want to convert decimal, the number that we know, to, let's give octal. Okay, let us see. For example, if you give decimal 8, and if you click on convert, it actually converted to binary. If you see 8 in binary, it's actually 1000, and octal, it's 8 itself. No, in hexadecimal it's 8 itself, and in octal it's actually 10. If you see here, it's 10. Yeah, decimal, it's already a decimal, so it will show the default value itself. In this way it exactly works. Or for example, if you want to convert hexadecimal to binary, and if you click on convert, anyway it will show all of them. You can convert in whatever way you want. For example, if you want to convert binary to octal, then it will be 10. binary to decimal, then it will be 8. Binary to hexadecimal, it will be 8. Like if you want to convert a particular thing, you can just click on that convert button. It will convert in all forms so that you can use the form that you want. Pretty simple, right? So let's work on this particular logic. For that, we are going to create a window, and we are going to, divide this window into two interesting frames. One will be frame up and one will be frame down. In frame up, you'll be having this numeric based converter. In frame down, you'll be having these interesting widgets. So yeah, let's work on it. If you observe the editor, I already created the code for, Windows. I'm gonna use these colors, which is white, black, blue, orange, and light blue, which are these colors. Okay, and I'm gonna use a theme called Clam so that, it follows the design well, because in previous projects I didn't use a theme, so the design looks a bit, it's not that good. If you want, you can use a style class. You can follow the style with me. Okay, so, and also give window dot resizable, just give width equal to false and height equal to false, so that it will not mess with the design. And just give background color as white. Yeah, so it looks something like this. Okay, now it's time to work on the frames, but before that we want a TDK separator line, which looks something like this. Okay, so that it looks good in the API. Let's work on it. So just give tdk.separator. We need this in window, and just give orient equal to horizontal, and just give dot grid, row equal to 0, column span equal to 1, and just give itad x equal to 190. And if you, we got a separator something like this. Actually, if you observe in the previous tutorials, what we did is we created a variable, and in that variable we actually initialize the widget. And once we are done with this thing, we use grid in the next line, right? Yeah, we can do something like that, and we can directly use, or you can even directly use dot grid as well. Okay, it reduces the number of lines. Now it's time to divide the window into two frames. One will be frame up and one will be frame down. So yeah, let's do it. Let's give frames, frame up equal to frame we need this in window, just give it 400, height 60, background color as color 1, pad y equal to 0, pad x equal to 10. I think it will be easy like this. Frame up dot grid, row value will be 1, column will be 0. Okay, and we just gave background color as color 1, which is black. Let's see. Yeah, so this is what we created. Instead of black, we'll give blue, which is color 2. Yeah, we need something like this, or you can just give white for now. Okay, now let's work on frame down. Copy this entire thing. Frame up, just give down. width 400 and height 300. Background color, let's give black so that we can check whether it's got created or not. Just give pad white 12, pad x0. Just give row value will be 2 and column value will be 0. Yeah, let's see. Yeah, we want something like this, but we'll change color. Let's give white. We actually divided, but you can't see. That's it. So now let's work on the app name. So just give app name equal to label. We need this in frame up. Just give text equal to numeric base converter. Just give anchor equal to center. Font, we'll use a different font this time. Every time we used to use Arial Ivy, right? We'll use system 20. Just give size 20. Let's give background color as blue, which is color 2. And foreground color as black, which is color 1. Let's place this one. Just give app name dot place. X will be 10. Y will be 15. Yeah, we want something like this, but there is a little space here. Give X value 3. Yeah, it looks better. Okay. Now let's work on these things. The widgets in frame down. So let's create a combo, but in order to show the options in that, we need a list, right? So first let's work on creating that list. So just give basis equal to binary. We want binary, we want octal, we want decimal, we want hexadecimal, yeah, we want these things, and now we are going to place this in combo. So just create a combo equal to tdk dot combo box. This one. We need this in frame down. Width equal to 12. Just define center. Font IV12, just give bold. And also give combo values equal to, just give basis. Basis is this one. And combo dot place X value 35, Y value 10. Yeah, we got something like this. If you don't give style here, for example, if I keep this in comments and if you run this one, see the style, there's no style, it's just a basic one, right? If you follow the style, the combo box looks a bit different, right? It looks good now. So we'll use the style. Okay. Now it's time to work on the entry, which is something like this, which looks something like this, and one button. So just give e value, which is entry value, equal to entry. We need this in frame down. Just give it 10, justify center, font, just don't give anything, but give size 30. Just give highlight thickness as 1. Just give relief solid so that you can see the entry. E value dot place, X value 160 and Y value 10. I already played with these numbers, so even you can play with them once you feel comfortable with it. Yeah, see, this relief equal to solid is the thing which is, making this entire thing as a border one, bold. Okay, now it's time to work on the button. So just give button converter, which is B converter, equal to button. We need this in frame down. Just give text equal to convert. Just give height equal to 1, background color as white, which is color 0. Let's see. Just give foreground color as black, which is color 1. Just give font equal to Ivy 8, bold. Relief equal to raised, because it must get look like a button. Just give over relief equal to rich. Yeah, it's time to place. So B converter dot place. Give X value 255, Y value 10. Okay, we got a button, but let's give some more color, some color which is light blue. So just give color 4 here. Yes. Okay, now we have a combo box, entry to give the number, and convert. Now we'll work on these things. So first let's work on binary labels. Just give binary equal to label. We need this in frame down. Just give text equal to binary, width equal to 12, height equal to 1, anchor equal to northwest. Just give font Verdana. Size 13. Background color, let's give orange. Background color 3. Foreground color, just give black, which is color 0. And yeah, let's see. This is actually color 1. And let's place this thing. So just give L binary dot place. X value will be 15. And Y value will be 60. Yeah, we need something like this, but let's give white so that white is looking better than black. So just give white here. Foreground color 0. Yep. Okay, now it's time to work on one more label, but this time we'll copy the same thing, because we are going to use this label to show the numbers which are like after converting. So that's what we are going to do here. But here the foreground color will be white, which is black, color 2, and here the background color will be white and the foreground color will be black. And that's it, and we are going to place it which is besides that label, besides this binary label, right? So just give X value, just give this one 35 and we'll give this one 170. Y value will be same, and if you're doing this one, and just give delete equal to solid. Yeah, it looks something like this. You guys cannot see, but if you give relief equal to solid, you can see, I think. But instead of using this relief equal to solid, we'll give background color, which is light 1. So just give color 5 equal to and here just give that color 5 as background color. And also delete this relief equal to solid so that you guys can see it. Yeah, we'll use this color for showing the numbers. So similarly, we are going to create for octal, for decimal, for hexadecimal as well. So yeah, let's do it. So yeah, I just created those 4. You just have to copy of that L binary and paste it. You will get, just follow that. But the thing is, for L binary, for label, just give 35 and 60, and for text, just give 170, 60, and here 35. It is same, but the thing is you have to change Y. Just give 40 pixels away. Okay, this will be 60, 60, then it will be 100, 100, and just give 40 pixels away, 140 and 140, and here just follow this order. Just give X value 170, 170, and 170, 170, and here just give 35, 35, 35, 35, and here just start with 60. Just give 40 pixels difference. That's it. And even I'm not using this color anymore because the default color is better than this background color. So I deleted this background color. If you observe here, there's no background color, but the foreground color is actually color 4, which is this one, light blue. So let's change this color 4. I just gave this for demo. So just instead of color 4, just use color 0. Because black looks good. So just give black here. And yeah, that's it. And if you run this one, so yeah, this is how it exactly looks. So the default color is actually good. It's better than the color that I picked. So yeah, I'm gonna use that color itself. If you click on here, if you give the numbers, it have to convert, right? Now let's work on this logic. Before working on this logic, I want you to understand how these decimals or how these number systems are going to convert from decimal to hexadecimal, decimal to octal. For that, you don't have to do anything. You don't have to write any logic for that. There are already built-in functions which are there in Python. You're just going to use them. How? Let me show you. First, let's create one more file called test.py. So here we are going to change the game. So let's just create a method called number to decimal. The reason why we created this function is whatever the number is, first we'll convert that particular number to decimal, because it is really easy to convert any number to decimal. For example, if you see here, if you study these number systems, for example, personally, while I'm studying these number systems, it is really difficult to convert octal to hexadecimal or octal to binary or binary to hexadecimal or, hexadecimal to octal. It is really difficult to convert. But once you know how to convert decimal to hexadecimal or decimal to octal or decimal to binary, then it will be really easy. For example, you want to convert this octal to hexadecimal. What you'll do is first you'll convert this to decimal, because this is really easy than this, and then you'll convert this decimal to hexadecimal. This is what we are going to do. Whatever the number that user is giving, if that number is octal, if that number is binary, if that number is hexadecimal, no matter what type of number is that, first we are going to convert that particular number into decimal. And once we are done with that, then we will convert that decimal number based on the user requirements. That's what we are going to do, and this is really easy. So first we'll create this basic function which is called number to decimal, where we'll give two parameters. One is number and one is base. Base is nothing but the base that we are following here. For binary numbers, the base is 2. For octal, the base is 8. For decimal, the base is 10. And for the hexadecimal, the base is 16. So that's what we are going to do. So here we are going to give two parameters. So just give number, base, and we will convert that number to decimal first. How? Just create a variable called decimal. Decimal is nothing but integer in Python. So just give that number and base here. This will convert it to integer and it will get stored in decimal. Once we convert to decimal, we'll convert that decimal to binary, octal, and hexadecimal. How? Just create a variable called binary. There's a method called bin in Python. You're just going to pass that decimal as parameter here, and we are going to create octal. If that number, if the user want to convert that to octal, just give oct and send that decimal as parameter here. And also, if you want hexadecimal, there's a method called hex, and just give decimal. And that's it. Here we have binary, octal, and hexadecimal. If you want to see it, so just give print decimal plus decimal, print octal plus octal. Print binary or hexadecimal. Just give hexadecimal. If you want binary, just give binary. This is to see whether the numbers are getting converted or not. And now if you give, for example, number equal to, let's give according to this table. For example, we want to convert octal to decimal. This number is 12 in octal and we want this number to get converted to 10, which is in decimal. Number equal to 10 and just give base equal to 8. That means we sent octal to the function, and if you call this number to decimal, with these number and base as parameters, and if you run this one, there's an error, right? Can't convert non-string with explicit base. So we cannot convert the number which is in number. So just give it as a string and let's convert this one. And one more thing is we need this one to be in string, right? Because we cannot concatenate two strings. We cannot concatenate one as a string and one as some data type, right? So we can convert it to string. So just give string here. It will solve our problem. And even here. Even here. And yeah, that's it. Now if you rerun this one and you gave the number as 10, so it got converted to decimal, which is 8. 10, right? You gave 10 and you gave the base as 8, which is octal. So this octal in decimal is 8. So yeah, it's in decimal, which is 8. In binary, it is actually 1000, and if you see here, you have 0b, right? This is actually representing that the number is actually binary. You have to delete these two things, and I'll show you how. And this is actually 0o is actually the code for octal, and the actual number is 10, which is this. And hexadecimal is 0x is actually code, and the hexadecimal is actually 8. If you check the table, that's what exactly here. 10 is actually 8 in hexadecimal. So in order to delete these two things, you're just going to use slice method here. Just give two and semicolon, and even here 2 and semicolon, and even here 2 and semicolon. And if you run this one, this time you are not going to see those codes here. Binary just 1000, octal just 10, hexadecimal just 8. That's what it is exactly. First, the given number to decimal, and once we converted that given number to decimal, we are going to convert that decimal to binary, octal, and hexadecimal. Now we are going to connect this logic to the API that we created. How? We are going to copy this entire function, and here when user clicks on this convert button, it must convert the entire thing, right? So when user clicks on this button, this function will be running in the background. So just, where's that button? B converter, right? Button converter. So just give command equal to convert, we are going to create this function within 2 minutes. So we'll create this function here. So just give def convert. Inside this function, we'll run this function. And yeah, that's it. Just copy this entire thing and give it that. So here we got number to decimal, number, base, decimal, everything is fine. But the thing is, instead of getting numbers like this, we'll get the numbers from combo box and entry, from these two things. From this combo box and from this entry, we are going to get the numbers. So just give number equal to eValue.get and combo base equal to combo.get. First we'll be getting combo, right? So just keep this on top. Base equal to combo.get and number equal to eValue.get. And once we got these two numbers, we are going to print these numbers. But before that, we have to set the base. Because here, if you run this one, we are getting the number and we are giving the input, but we are not setting the base exactly with, if you see here. Just user just know that it's binary, but computer must know that for binary the base is 2, for octal the base is 8, for decimal the base is 10, for hexadecimal the base is 16. So we have to set the base once the user gave that input. So if this input is binary, we'll give base value as 2. If this input is octal, we'll give the base value as 8, something like that. So just give if base equal to binary, just give base equal to 2, because for binary it's 2. Similarly, elif base equal to octal, base equal to 8. Similarly, if base equal to decimal, just give base equal to 10. For hexadecimal you don't have to give because that's the only thing which is left, so just give else base equal to 16. Alright, if you call this function number to decimal, it will take the base and it will take the number as parameters, and it will go to this function and it will convert everything and it will print these things. But instead of printing, we want this to be in the labels, right? In these labels that we got, that we created. These are the labels that we created, so we are going to configure these label texts. We are going to fill this with these things. Instead of printing here in the console, we are going to print them inside the API, inside that labels. For that, just give label binary equal to label binary of text. Okay, text equal to this string binary. I hope you guys are getting it. Just copy this and paste it here. Similarly, do the same thing for octal. Label octal of text. Just this one. Do the same thing for label decimal. Use this one. For decimal, you don't need extra things. And label hexadecimal. Equal to just this one. Now delete these things. And these L binary, L octal are actually these things. L binary, L octal, L decimal. These are the texts that we actually fill in with this logic. And if you run this one, now if you give, for example, decimal and just give 8, and if you click on convert, just give foreground color as 1. If you run this one, and if you give decimal to convert, and yeah, this time you can see in binary it is actually 1 0, in octal it is actually 2, decimal 2, hexadecimal 2, and let's see whether it's working according to the table or not. You actually gave decimal number as 2, right? In binary it is actually 1 0, yes. In hexadecimal it is actually 2. And now let's give, for example, decimal number as 10, which is 10. So just give decimal as 10, and if you click on convert again, hexadecimal is actually giving in lowercase. We must need this thing in uppercase, which is capital A, capital B, right? So we have to change this to uppercase. So here, just give dot upper. If you run this one, for example, you gave decimal, just give 1 5. Yeah, this time if you see, it is in capital. So whatever the type, whatever the base, or whatever the number that you're giving, it will convert to all types. It will come to binary, octal, decimal, and hexadecimal. And I think you guys understood how everything exactly working. If you like this video, then hit that cute little like button. If you're new to this channel, and if you still didn't subscribe to this channel, what are you waiting for? Just go there and tap the red button so that you guys never miss an update from us. I'll be back with one more interesting project. See you in the next video.